lasagna for breakfast.
All right.
Okay?
All right, guys.
I'm gonna be at
Page 156. Let's wrap this up. Okay. We're going to kind of tie the probability now into when we do how many ways or how many are there. So we have an example 8 in your book. And we did this with your distinguishable permutations. A word consists of one M, 4 I's, 4 S's, and 2 P's. So you have one M, 4 I's, 4 S's, 2 P's. Yeah, well, altogether, how many letters do you have? 11 letters. 11 letters. Okay. They want to know what is the probability that the arrangement spells out the word Mississippi. Okay? So, how do I find the probability that out of all the possible arrangements, I will get one that spells out Mississippi? Here.
Okay, well, from the notes from yesterday.
Yeah, from our distinguishable permutations.
You want to use combination or permutation?
Well,
Order does matter, so only permutation. Alright, so we got to do He's alright if I just go up on the board and try it right?
No, just explain to me.
Alright.
Guys.
Well,
Okay, hang on.
so 4 plus 4 plus 2 plus 1. That is 11.
Yes.
So you'd like to do 11 and then P. Yeah, there we go. That's it.
Do this too. And
Divide
divide it by
Five.
all your duplicates.
Yes. That's
Okay.
coming up.
Nice.
and then
And then,
you take the answer
yes,
and put it under R.
very good. Joe's got the rest of it. This was a group effort. Darren and Ben and Joe pulled this all together. So, if we do this, guys, all of those people. It's taking us a long time to get into this group today for some reason.
Oh, I'm getting you.
Okay, there are 34,650 different arrangements. Guys, you with me? There are 34,650 different arrangements to be made from these 11 letters that are distinguishable, that are unique. We want to know the probability that it spells Mississippi, so Joe helped us out, and he said 1 over this total. Remember, probability is part over whole. So there's only one way to spell out the word Mississippi.
Distinguishably, but
Yes.
you can switch to other eyes.
But we took care of that with this. Because otherwise we would have just had 11 factorial, and then you're right, they would not have been distinguishable. We would have been able to switch the S's, the P's, the I's, but we took care of this by taking it out of here. So this allowed us to get only one way to spell Mississippi.
Okay.
So now, because it said the probability, you have to, probabilities we fall between 0 and 1. This is not, 34,000 is not a probability number. So we had to make it a probability, part over whole. So you guys try the next one. And it's asking for a probability. It wants a probability, guys.
Is this title order?
How many letters do you all have altogether?
6.
Okay, so I want to know what is the probability that these letters can be arranged to spell the word letter.
So if you'd like to do 6 factorial divided by will you do 1 factorial or no?
No.
Alright, 2 factorial and 2 times 2 factorial.
Okay, so this will give you how many distinguishable arrangements can you make? Yes. 180, guys. Shh. Okay, how many of those arrangements will actually spell the word letter? 1. So the probability of spelling this word is 1 over 180.
Because we took out I know they're both 1, but since we took out those 2, does that affect it anymore?
No. What we did was we took out a duplicate E. Like we didn't allow the E's to be switched. We didn't allow the
I
E's
mean,
to be
like the
switched.
L and the R, we get rid of like the 1.
Oh no, 1 factorial is just 1.
Okay.
You only have to take out the duplicates.
Okay.
Okay. I don't know why I'm recording this group. All right. Last 2. Ready? So Gunnar, you want to read this one for us?
Yeah, I got it.
Go ahead.
Example 9, right?
Example 9.
Find the probability of being dealt 5 diamonds from standard deck playing card and focus is all.
Okay. I want 5 diamonds. Does it matter what order my diamonds come in?
No.
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 So, combinations. How do I set this up?
You 5.
52.
Okay, 52, C, 5. So okay, hang on. If I use 52, what does that 5 give me?
All out of all the cards.
Out of all the
You have to
cards.
Just take a diamond.
Okay, hang on to your 4C1 for a second. Out of 52 cards, this is the probability of picking any 5, right? How many ways can I pick any 5?
1 way.
Okay, but that's what this tells me.
2 million.
Any 5.
Well, we want to get 5 diamonds. 14
Okay.
diamonds.
Okay, there's 13 diamonds.
So it's 13 shoe spot.
13, C, 5. This is the combination of choosing any diamond. Now,
Multiply this together.
no,
It's over.
I want a probability. Good.
So
Probability
one-
is
1,000
part over whole.
1,287.
Oh, okay, so before you give me the numbers, tell me how to set that up. How do I set that up?
So it's 13 shoe 5 over 5.
Good.
Miss, could you factor it out and get the actual numbers first, then divide it?
If you wanted to, but I would just do it on my calculator. God bless
I
you.
can do all that? How do I do all that? Here, look. I know you do
Guys?
It's the same as where the
Man.
Okay,
This.
so this was a good, guys, this was a good way to pull this together. We needed the bottom number. This is the bottom. This is any 5. And then we wanted the any diamond. And we knew that it was combinations because it didn't tell us any specific order. So this is the perfect way to set this up. The bottom one, I call this the generic one. Any 5. Doesn't matter diamonds, doesn't matter. Just the combination of any 5 cards at a time. How many ways can we do that? That's what we're looking at on the bottom. And that comes out to be, I don't know if they worked it out,
1,287 over
Whoa.
over
2,598,060.
2,960. There's this many ways,
Wow.
different combinations of pulling out any 5 cards out of your deck. So Ben, how many combinations do we get of pulling out 5 diamonds?
1,287.
Thank you. There's your probability. Part over whole. Any 5 versus the 5 diamonds. This is the generic part down here. Okay? Try it yourself, number 9. It's right at the bottom of page 156. Take a minute and see if you can figure that out. Remember, probability is part over whole.
You just leave the answer as that. You want to go and start?
You can reduce it if you want, or you can just leave your probabilities like that.
Yeah, because I typed it all as one fraction and everything.
It'll still reduce to that, probably because of this.
Oh, knock out your really scary number.
A decimal, you can leave it in 3 decimals. Okay, so what does that say, Gunnar? What does it say?
It says 4.95, 198, 0792, e to the negative 4.
E to the negative 4. This is an exponential number. This stands for, this is your exponent. So this says move this. This says move this decimal 4 to the left. 1, 2, 3, 4. Shouldn't this be a very small number? I mean, look at the difference between those. Shouldn't this be a very small number? So whenever you see this e to the negative something, that's your scientific notation number. Move it to the left this many places. It's essentially, just give me 0.00. And if you round this off, you have to round to a significant number. So round to this, 0.005. It's way less than 0.5%. Okay, now try the next one. Try it yourself, number 9.
I think you're right.
I believe so. I'm not sure though.
Okay, always start like this. 5 men,
If there were 5 men,
7 women.
12 C5.
Generic on the bottom.
Right, so then you do 12 C5.
Yeah, but it's hard.
Oh, over again as well?
Overall. But you might be right.
I don't know. I think go either way.
So how did you do
If you want that to be on 10, so it would be 3 out of 5, and then 5
Not bad, right?
So it's 3 C5 over 12 C5.
Okay, so we have,
You're right.
okay, this is the generic part. Any five, whoops, we want 3. Any 3 people at all. If I have 12 people, how many different ways can I choose 3 people? Order does not matter. That's my generic part. This is the bottom. The top part is specific. It says choosing 3 men. I only have 5 men to choose from. So how many different ways can I choose 3 out of the 5 men? Goes on top. And this goes on the bottom. This is the way you set this up. Always look for this on the bottom. The generic part. Any 3. On the top is your specific part. Part at a whole. If I said 3 women, what would go on top?
That'll be 7 to choose 3.
Okay? Now, what if I said 1 man, 2 women?
Sounds like 6.
12.
How many men to choose from?
5.
5. Oops, or how many do we want? 1. How many women to choose from?
7.
How many do we want?
0.
And bottom number stays the same.
So you multiply the top 2?
Yeah. Yeah. How about if I wanted 2 men, 2 women?
5 to 7
7C2 over 12C4.
Oh, but I can only choose 3. I can only choose 3 people.
Yeah, but 2 men and 2 women are 4.
So therefore, what's my probability? Can't do it. 0. Tricky. Yes, tricky. What if it asks for choosing 6 men? You would have to also say 0, right? Because you only have 5 men. Okay, so let's review some of these to finish up the day with here.
Mr. Moore, you're the greatest math teacher ever.
Yes.